Hello all, today we are solving LeetCode problem number 3651, minimum cost path with teleportations. So you are given a 2D integer array named grid, which is of dimension of m cross n, and we are given an integer k as well. And you can start at top right of the cell, which is at position 0 comma 0, which means you are given a grid m cross n, and you can start from 0 comma 0, and your goal is to reach the bottom right cell, which is m minus 1 and n minus 1. So in representation, if you have a 2 cross 3 grid, right, so you have two rows and 1 2 3 columns. So this is, so this is the 0 0 position, and you have to reach this position, which is m minus 1 and n minus 1. So this is your task, and you should have some sort of moves to reach from 0 0 to n minus 1 and n minus 1 position. So there are two types of moves basically. One is move right, so that is in position ij to ij plus 1, moving right, that is right of the current cell, which is ij to I and j plus 1 position. So similarly, moving downwards from ij to I plus 1 j, and cost of this movement is the value at destination cell. So for example, you are at ij, and to move to this position, the cost at this I and j plus 1 position is the cost for this movement. So now the type 2 is teleport. So from ij you can move to any cells within the grid, but that should satisfy a condition, that is grid of x y should be less than or equal to grid of ij. For example, you are at grid the first one, which is 5, and your destination is 6, and this is 5, right? So since grid of x y grid of ij will be 5, you should find out some value. For example, if we are having 1 2 3 4 1 2, in this case you have to find a grid which is less than or equal to, that is starting position is 5, so 5 less than or equal to values you should find out from the grid, and you can jump to any such position with cost of 0. So there is no cost. And how many times can we do this? Up to k times. So that is what given as an input, so up to k times we can do this. So then output here is return minimum total cost to reach the destination. So that is the output. So from grid of 0 0 to grid of m minus 1 and n minus 1, so with minimum cost. So that is what we have to return as an answer. So how do we solve this? First observation is, this is just a moves, right? Totally we have two types but three moves. One is you can move right, you can move down, or teleport, right? So basically you have three decisions, and again after moving right, you will check if the position is m minus 1 or m minus 1 and minus 1 now. So you will continue the same position, again 3 moves, and similarly this will have 3 moves and 3 moves. So this forms a decision tree, so in such a way that we are solving sub problems, and we will be getting the output for the complete problem, right? So this is nothing but we can do by dynamic programming, DP. So let me run through the example one, and we will understand the approach of performing the implementing the problem with dynamic programming. Because since we have 3 moves here, This will be we have to track down those two right and down along with teleportation. So this will be 3D DP. So this can we can do as 2D DP for right and down, and this is 1D array we can use for teleportation. So using this we will be solving running through the first example. So let us start. So initially this is the example which is 1 3 3 2 5 5 4 3 5, right? And first as I discussed, we are having a cost DP which will find cost for actually this will be a min cost for right and down moves, and this uh, teleport cost DP, this is for min cost for teleportation. So we start with for loop for teleport for t, and then we have two for loops for the cost dp, I and j for cost dp, right? So now we start with teleport equal to 0. So in this point 0 push 0 teleportations, we will not be doing any teleportation, so which means we will be finding we will be running through only by right and down direction, and we will be calculating the minimum cost to reach the destination. So we follow here bottom up approach. So we start at this position, let me change the color. So we start at this position, right? So now for we can come to this position because to reach from 0 this is the destination, so there is no requirement of calculating anything here. So we come this point, and now we can see that from this point, which is 3, we have to reach the destination, which is this which cost 5, right? So now we have the actual value as 0, and to move from 3 to 5 it cost 5, so hence it will be 5, and remove a minimum of infinity, and minimum of infinity and 5 is 5, so update this with 5, right? And now we can come here. In this position you have 4 at 4, you have already the existing other value as 5, and from 4 to 3 to move to 4 to 3 you need 3 cost, right? So adding with 5 this will become 8, which means already the aim is to reach from this position to the destination. So that is why we are tracking down the accumulated value for accumulated cost value, in fact, right? So that is nothing but 3 plus 5 is 8. So here the accumulated cost is 8, but when in case of this position this changes, right? So we will come to this position which is here. So from here to this position reaching, there is no right, the right moves, only down moves is available, no right because no values are present here, so only down moves is there. So to reach this position it is 0 plus 5 is 5, which is less minimum compared to the infinity, update by 5. Now at this position, so from here we can go right, and then come down, right? So because of that, to this position cost us 4, so 4 plus 5 is 9, and we also can go down and then right, so because of that this will be 5, this is the existing accumulated value, 5 plus 3 is 8, which is 8 is less than 9, so update this with 8, right? So similarly we can repeat this, and in the end we will get, I will update this with the value in the interest of time. So 12, 9, 12 and 14. So this is the first in the zeroth iteration you will have the cost dp as this, and now you have to calculate the minimum cost. So to calculate the minimum cost, let me erase these down. Yeah, so to calculate the minimum cost, what you have to do is iterate through this array from left to right, each by row, and then we at the value of grid of ij. So if we have one, you have to, before that we have to initialize the array, right? So how do we determine the size? Because we have to find the maximum among the grid, the value which is maximum among the grid, and we have to fill in that. I mean, if we have to create a array of size maximum value plus 1, because we are following zeroth index. Why is the reason? Because from that position you can move to anywhere, any grid position, because following the condition, if grid of I j is less than or equal to grid of x y. So based on this we have to find the maximum value so that we can reach to any grid, any position in the grid. So you create the array of size that plus 1 because of the zeroth index. So 0, 1, 2, 3, 4, 5. So now you have to traverse this grid, and the first value is 1. So at position 1, okay, you can see here the minimum value is 14. So hence you can update this with 14. This will be 14 for now, and we will be coming here. This is the value is 3, and you can see it is 12. So minimum of infinity and 12 is 12, and again we came to this position which also has 3, and the value is 9 here. So minimum of 9 and 12 is 9, so update 9 here. And now we can come to this position which is 2, so which has 12, so update 12. Then 5 which has 8, so update with 8. Then followed by 4 which has 5, update by 5. Coming to here we have 4 again which is 8, but 5 is a better value, so keep 5. And 3, now we have 5 here, so we update, minimum is 5, so update by 5. Now we come to the last position which is 5, which has 0, so minimum of 0 and 8 is 0. So the newly formed teleport cost array is 3, 4, 5, 6, will be infinity, 14, 12, 5, 5, 0. So the first iteration is done, and now you never performed any teleport operation. So in the next one, the updated value becomes 1. So now we can use the teleportation value with the help of this array, the t cost tp array, right? So now we can again start from the beginning. So we will be at this position. So from this position to reach the destination, the best way is to move right. So this cost us again 5, operation 5, so this remains 5, right? And now coming to here 4, you can and before that you have to check the value 3 here. So if you can see here in this t cost dp, 0 1 2 3 4 5, the value here is 5, so minimum of 5 and 5 is 5, so let this be 5. And now again from 4 to 5 the old value is 8, and you can see here from 4 you can reach to 5 by 5, so minimum of 8 and 5 becomes 5. So I'll remove this, update by 5. So you have to now here I will write an equation just to compare min of t cost dp of grid of I and j. Okay, this should be compared with cost dp of I and I and j. So minimum value between these two you have to find and then update back to the cost dp, right? So that is what we are doing here. So now coming here at this position, again you will be calculating the cost dp. Because of this you will have 5 here, and now you will look into this t cost dp, where from 4 to 5 4 to destination the value is 5 here, minimum of 5 and 5 is 5, so 5 remains 5. Now you come to this position you calculate the value, and you can see by performing the right and down operation you can reach to this position by performing 8 cost, right? And if you look in this array you can see here it can be done by 0 cost, so that is what the teleportations they are doing. So it is 0 cost, so because of that minimum of 8 and 0 is 0, so update this with 0, right? So now you're coming back to here from 2 to 2 to destination, the value is 12, so remains 12. And now you can see here from 3 to destination the value is 5 here, and by from here we can traverse go down and down, which will cost us 9, so minimum of 5 and 9 will be 5. And similarly again this will be 5, and similarly this will be 7. So you get the new cost dp with the result of this, right? So at the end of iteration t equal this is t equal to 2, so you get a new matrix where we had the cost dp matrix 0 5 5, this will be 0, then 5 12 7 5 5. Oops, this should be 5 actually, because we will be comparing this, right? The way we are traversing, right? So we can reach here, okay, which will cost us, or no, this will be coming in the third iteration, I'm sorry about that. So let me write it down. So 5, this is also 5, and this 2 5 5 and 7, so t equal to 1. So now before moving into this iteration you have to update the cost dp, right? Because we haven't done that, we have just updated the cost dp. T cost dp is not updated, so now you have the values as infinity, 14 12 5 5 0, right? So now in this iteration you can Again you have to do a check with the actual matrix value. So let me write it down, the actual matrix value also here. One, three, three, two, five, four, four, three, five. Yeah. Yeah, again we start iterating through this one. So one at position one. Now we have the updated cost TP, right? So at position 1, 0, 1, 2, 3, 4, 5. So at position 1 the value here is 7, so update this with 7. And 3 the value is 5, so this remains 5. And now even this will be 0 for 5. And similarly what else are remaining? 2. So in this 2 this is 5, so update with 5. And 5 is 0. Then 4. For 4, do we have any better options? It will be, yeah, this will remain 5 only. So we got the new updated matrix, array. So infinity 7, 5, 5, 5, 0, 0, 1, 2, 3, 4, 5. So this is the output at the end of T1 iteration. Now T2. So we will repeat the same thing similarly, right? So we will do the same operation, updating the DP with existing uh, or the previous T cost DP. We will be performing the operation, and eventually we will be getting the cost DP out of it. So we have to return the cost DP of 0, 0, which is nothing but 7. This is the minimum value. So from this we can say that because this is the starting point. Let me just run through this matrix only. So this is the starting point, this is the destination. So starting point is here and destination is here. So we can perform two operation and come here and perform 5 of moving right and come here, and now teleporting we can come to this point, which is the destination, so which is nothing but 7. So with all this observation, let us go ahead and code this out. The time complexity for this problem will be big O of we have k, so k cross m and n, where m and n are the sides of the grids, which means the row and column of the grid. And we are using teleport matrix, so sorry, it's teleport array to calculate the cost for teleport cost. So because of that will be of size m, that is the maximum size of the maximum value present in the grid basically. So this will be the time complexity, and the space complexity will be, we are using a grid for finding the cost dp, and we are using a array for finding the teleport cost dp as well. So we have mn plus m. So this will be the space complexity. So let us now code this. So n is equal to len of grid, and m is equal to len of grid of 0. So we calculated. Now we have to define the cost dp, right? So cost dp is equal to, we are assigning with the infinity value. So inf, this should be multiplied with for m times, and iterating for in range of n times. So we have now created a cost dp basically, so through which in the previous the explanation where we saw how we are building the cost dp and following the bottom up approach, right? So the destination or the starting point is the last part, right? So which is the so we can access that by cost dp of -1 and -1, which is nothing but 0, right? So now we have to build the teleport cost dp, so which is t cost dp, which is an array. Again, this should be initialized with with the value infinity, so inf multiplied by this should be maximum value present within the grid, right? So how do we find it? Max of iterating through the complete row in the grid, right? So this should be max of row for row in grid added with 1. Now we have built the total this teleport cost tp, and now we have to update the values in the cost tp as well in the teleport tp and return it, right? So for t in range k plus 1 times, because the value here is non-inclusive, so that's the reason why we are adding with 1, and we are iterating reverse from the reverse. So for I in range, this should be n minus 1 and -1 and -1 times, and for j in range, again m minus 1 starting at -1 until -1, then decrement by -1. So now we have to write for we have to fill in the cost dp by moving right, moving down, or performing the teleport, right? So for move right, if I is lesser than n minus 1, in this case let me copy this cost dp of ij, copy this completely, is equal to min of the existing value, yeah, and this should be I plus 1 and the grid value here added with the grid value, right? So cost dp of I plus 1 added with grid of I plus 1 and j, right? So let me pull this here, yeah. So now similarly the next should be moving let me copy this first. So next should be moving down, so paste this. Now this should be replaced with j, and here the same cost dp will be there, and now this should be changed because we are moving down. We have to do the operation in j index, so 1. So yeah, now we are performing teleport, right? So for teleport, just copy the same, and we have to replace with values, but here this is not with, this should be m minus 1, and for this one we are using t pointer should be greater than 0, right? So in this case cost of I is equal to minimum of cost of ij, and this should be compared with the teleport cost dp value, right? So teleport cost dp of this should be grid of I and j, right? So now filling this part is done. So now we have to compute the uh, teleport cost for the next t, right? So let us come out of these two loops. Yes, yeah. So now compute the teleport cost, t cost tp for next t. So now for I in range till n and for j in range till m, right? So now t cost of grid of I and j is equal to min of the same now this should be compared with the cost of ij. This sorry, cost dp, my bad, cost dp of ij, right? So now again the last thing is you have to compute the prefix minimum, right? So for that again we will be performing the operation in this t cost dp. This is t cost dp. Let me again copy this name, and for I in range len of t cost dp, and now to t cost dp of I is equal to min of t cost dp of I and the previous one t cost dp of I minus 1, right? So yeah, I think we have to start from 1 because we are performing -1 here, right? So this we should start from 1 because 0th index this will cause a problem. So this should be not here, I'm sorry, this should be 1 and len of this, right? Len of t cost dp, right? Now we have computed the prefix minimum and updated the t cost dp value, and now we are good enough and we can go ahead and return the cost dp of 0 0. Return yeah, return cost dp. So cost dp of 0 0, the first topmost value. So let us run this. Yeah, it's working. Let me go ahead and submit this. And it's a pretty efficient solution. Thank you.